Hello, everyone. Welcome. Yeah. Yeah.
Closer to the mic.
I have a mic right here. Okay, I guess I just need to speak louder. I'll try.
I'll move this closer.
Okay. Sorry. Yeah, my talk today is level up your Viz skills from Matplotlib to HoloViz. We will talk a little bit about Matplotlib and then how we build from Matplotlib to HoloViz. You can find my slides through this link. It's on my GitHub pages. So let's get started. Most of you probably don't know me. My name is Sophia. My background is in psychology, statistics, and computer science. I have been working at Anaconda for more than 4 years. I contribute to HoloViz and a few other open source Python projects. I also have a data science machine learning book club if you're interested in joining a book club. Yeah, so the reason why I'm talking about HoloViz today is because I'm an avid user of HoloViz tools. In my data science workflow, I actually need to build a lot of plots and visualization. That's why I fell in love with HoloViz and starting contributing to HoloViz. So I want to share with you my love, and hopefully you will get to know more about HoloViz. My Python visualization journey is actually starting from Matplotlib. I know everyone probably have heard and used Matplotlib, right? It's one of the first Python libraries that I have used and fell in love with. It is actually a very powerful tool that a lot of new users probably have not figured that out, but it's actually powerful. You can probably reproduce any kind of static plots you see on the internet on Matplotlib using some magic and some effort, hopefully. Here's the anatomy of a Matplotlib figure where you have a figure which controls all the elements you see here. And then the Matplotlib figure includes one or more axes. And then you can define all the elements in the axes and do your plotting. Again, it's a very powerful tool. You can pretty much configure every single element in your figure. And it can also render to a lot of different formats like PDF, PNG, SVG, and all the other formats. That's why it's well loved by academics. I know Tom just mentioned this in his talk. Matplotlib is actually used by 17% of the papers today. Note that the papers is not just Python papers, it's all the papers on archive, so it's actually quite impressive. Yeah, so shameless plug, if you are interested in learning more about Matplotlib, I recently created a course called Introduction to Python Visualization with Introduction to Data Visualization with Python using Matplotlib and pandas, plot, and seaborn. You can click on this link to go to the page. Yeah, so here's my slides again. Yeah, so why am I talking about HoloViz, right? So as I was working with data more and more in my everyday data science job, I realized I started to using a lot more high-level open source tools built on top of Matplotlib and some other open source libraries such as Bokeh. And I realized that I have 3 needs in terms of my visualization. First of all, I am quite lazy. I want to write as little code as possible, and if I don't need to write any code to explore my data, that's even better. And secondly, I want my plots to be interactive. I know Matplotlib can also give you interactive GUI and plots, but it's not built on JavaScript. It's not designed to be interactive in the browser. Tom can correct me if I'm wrong. So that's my second need, that I want my plot to be interactive. The third need I have is I need to build a dashboard. When we deliver deliverables to stakeholders, we normally need to deliver a dashboard. And in this dashboard, I want to include different types of plots, whether it is Matplotlib or Bokeh or some other plots. I want the flexibility in my dashboard. So, and then I realized HoloViz can pretty much satisfy all my needs. HoloViz is developed and created by 3 of my friends and coworkers, Jim Bender, Philip Rudiger, and John-Luke Stevens. It's sponsored and supported by Anaconda and many other fundings. It is completely open source, so yeah, if you want to contribute to HoloViz, that would be awesome. HoloViz is a Python visualization ecosystem. It's not just one package, it's actually 8 packages. In this talk, we'll mostly talk about the first 2, Panel and HVPlot. Panel is a tool for you to build a dashboard. So when we talk about a HoloViz dashboard, we're actually talking about a panel dashboard. HVPlot is the entry point for you to build a HoloViz plots. HVPlot also works with all the other tools in this ecosystem. For example, HVPlot works with Data Shader in the backend to do big data visualization. We'll talk about that in a little bit. Yeah. So here are all the topics I want to talk about HoloViz today. We want to start from the basic syntax. We'll talk about how do you switch between multiple backends for your plots. And then we'll talk about how to explore your data using HVPlot Explorer. How do we do big data visualization? How do we do streaming data visualization? How to create a dashboard? And then finally, how to do deployment. Yeah, I know it's a lot of content, but that will be high level so that you can get an overview of what HoloViz can do. And if you want to explore more and learn more, you can read the documentations later. So let's start from the basic syntax. Here's the Matplotlib syntax that many people are familiar with, right? You have you need to create a figure which contains a single axis or multiple axes, and then you can plot your data on the axis and set different attributes of your axis. Note that here I'm plotting a pandas data frame, we call it DF, with column X and Y. Oftentimes when I am working with pandas data frame, I am actually using the pandas.plot API. If I use, most of the time I use either pandas data frame or DAS data frame. In both scenarios, you can use the .plot API, right? It will return you a nice looking plot. And the syntax is quite easy. You can define your x-axis, y-axis, and all the other attributes of the plot. For HVPlot, yeah, if you're familiar with pandas.plot API, you'll probably find it really easy to transition to HVPlot because you can just change .plot to .hvplot. And of course, you need to import the needed modules like hvplot.pandas for pandas data frame. You can do hvplot.das for DAS data frame. It also works with Rapids, Xarray, and many other data formats. And it's all the same syntax. So the default of HVPlot is actually bokeh. That's why the plot you see here is a bokeh plot. Here is the bokeh logo where you can zoom and pan using those icons. What if you want to get a Matplotlib plot using HVPlot? Yes, you can. So again, the default is bokeh, but if you add this line HVPlot.extension Matplotlib, you will return a Matplotlib plot for you. And if you want to have a Plotly plot, simply add this line hvplot.extension Plotly, you will get a Plotly plot. Right, so it's super convenient. You use the same syntax and get different styles of plots. Yeah. And then the next thing, which I love a lot, is HVPlot Explorer. A lot of times when I work with new data, I actually don't know what I want to plot. I just kind of want to see everything. So with HVPlot Explorer, you just need to write this one line of code, hvplot.explorer, parentheses df, and then you get this dashboard where you can define what's the type of plot you want to get, what is the x-axis, what's the y-axis, what's the group by variables, right? So it's super convenient way for you to define your plot, and yeah, and of course you can add the title, labels, and styles, and others. Yeah, this is a tool I absolutely love. You don't need to know how to code to use this tool. It's just one line of code. And after you found a good plot that you love with this dashboard, you can call plot_code to get the code for this plot. So this code will give you the code of the current state of the dashboard, right? So if you want to copy and paste this code to your notebook and use it later, it will help you reproduce this plot later. Okay, the next thing I want to talk about is big data visualization. To the left here, we have pandas.plot API plotting 11 million data points of New York City taxi data. We plot the drop-off locations, the latitude and longitude, and it is a scatter plot. Notice that it is just a blob. It's really hard to extract meaningful information from this plot. I know some of you might think, okay, what if I just add a alpha value to increase the transparency? I've tried that. It still doesn't look very good. So with hvplot, you can see with a few lines of code, you can get a really meaningful plot really easily and really fast. You can see where exactly in New York you get the high density of traffic data and where you get less data, right? The magic of this big data visualization lies in this one line of code, rasterize equals true, where hvplot used data shader to apply rasterization, basically aggregate and counts your data and put into counts your data for each pixel of your figure. And it uses Numba, compiles our code to C code, that's to machine code. That's why it's like super fast to give you the result back. And of course, we applied the histogram equalization as the normalization method for this plot. You can also do a log or linear method to see whichever you think works the best for your figure. And then you can define the color map, which is the pretty color we have here, from dark to red and to white. And then for tiles, tiles defines the underlying Earth image so that we can overlay your plot on top of the tiles. Any questions so far? Sorry, let me drink some water. Yes?
Oh, so that works with any longitude, latitude to pull the
Yes, exactly. Yeah. Okay, so there are actually multiple ways to make this plot. You can also have the tiles defined separately and overlay your plots on the tiles figure. It's all okay. And yeah, so that's big data visualization. The next is streaming data visualization, where hvplot supports streams data frames. So on the top here, we have a function returning this is just a pandas data frame of your computer memory usage information, right? So the magic is this function, periodical data frame, where we feed in this memory data function and ask it to return a record for us every 300 milliseconds. And the returning DF here is not a pandas data frame anymore, it's a streams data frame. But hvplot works for the streams data frame the same way it works for any other data frames. We just do df, and here I have the columns, which is the used memory. And I plotted a line plot and showing 200 records of this data, and you can get a streaming data, real-time data really easily. Okay, next important thing is dashboard, right? I'm going to show you how exactly to build this dashboard in a second. So there are actually 3 ways to build a panel dashboard. So you can, if you click on this link, you can get to my blog post, which tell you the 3 ways hvplot are interactive, panel bind, and param. Those are the 3 main ways. There are also other ways to build a dashboard. It depends on your needs, and each of them gets more complex and handles more complex situations. And in this blog post, I show you how to build this one dashboard with 3 methods. So you can compare the code if you want. Okay, so In this talk, I mostly want to talk about hpplot.interactive, how to convert your pandas data processing pipeline into a panel dashboard. To the left here, we have a pandas data processing pipeline where we give it a name called pipeline, and it's actually returning a data frame where we use the data frame of the car manufacturer data, and we subset this data frame by the number of cylinders, manufacturer of their data, and we calculate the horsepower for each origin and miles per gallon. And then the returning data frame looks like this. This is the first 5 records. You can see the value of the average horsepower for each origin and each miles per gallon for your car. To make this pipeline interactive, so here are the code. You can do df.interactive to make your data frame a hpplot interactive hpplot data frame, and then you can define an interactive pipeline where instead of defining actual values of your the actual values here, you can just using panel widgets to manipulate the values you want to add here. For example, we have cylinders, which is a slider. You can choose the number of sliders easily here. And the manufacturer and also the y-axis is the variable we're interested in to calculate average on. Those are grouped button groups, so you can choose different values in your widgets, and then we'll show you different results. So it's quite easy, right? Okay, let me show you a demo very quick. So if you click on this link, it goes to a GitHub page where I have all the files here. I also have a blog post here if you want to read more. The main file we are looking at is hpplot interactive file. Here I open it up in my Jupyter notebook. Yeah, so this is what we said before. First of all, we make the data frame interactive, and then we make panel widgets. Here I can show you how the widgets look. So the cylinders, you can choose 4, 8, 6, because we start from 4, end at 8, and step is 2, so it's basically just giving us 3 values. And then if you want to take a look at manufacturer, you can choose different things in the y-axis that you choose between horsepower and weight. And then we combine the pipeline and widget to make an interactive pipeline where you can change different values. And then here we pipe it to a good-looking table where you can sort your table by different columns. You can see different pages. So this is just a better view for your table. And then similarly, we can do .hpplot as we have seen earlier. It's the exactly same syntax, but it also works on the interactive pipeline and the interactive data frame. And the resulting plot is interactive. Quite interesting, right? So weights and horsepower. And then finally, I used a template to have my widgets in the sidebar and have my plot and table showing in the main content. And then to serve this notebook, we can run panel serve. Panel serve will serve your notebook locally. And why is it not loading? That's weird. Sorry. Why is not defined? I swear you just worked a little bit earlier.
Any demo that doesn't break is a fake demo.
Yeah, it must be somewhere, like I added a Y somewhere. I'm I'm so sorry about this. I swear it wasn't breaking a minute earlier. Okay, this looks promising. Okay, yeah, I don't know what's going on. Okay, you can run template.show. It will just show up as a separate page. If we want to serve it, we actually need to do panel serve, but it should return the same thing. Yeah, I don't know, it should work. Anyways, you get the idea. I'll make sure it's fixed. I think if you clone the repo and run it in your own environment, it should work. Okay, so that's deployment. I just talked about panel serve, which is it does not only work with your Jupyter Notebook file, but also works with your Python file, standalone Python file. So you can write your app in either way. And the final thing I want to talk about is that panel allow you to convert your app to a PyData app or a PyScript app super easily. If you have went to the Fabio's talk this morning about PyScript, you will understand a little bit about how PyScript works in your browser. So this allows you to run your panel dashboard in a browser without any server needed. So what you need is panel convert, and then convert your app to WASM. So again, so hopefully this would work. We simply run panel convert, and your file. You can use PyData worker to run PyData in a separate thread. If you don't have PyData worker, just do PyData. You will run PyData in the main thread, and then you can output the files into a separate file called docs right here. And we look at docs. It will generate a HTML file for you and also a JavaScript file. The JavaScript file only show up when we have a PyData worker in a separate thread that handles the separate worker. Okay, so once we push that to our document, we can set up GitHub pages from the docs, and then you can see the app showing up on GitHub pages. As you can see, as we're loading the page, the GitHub page is actually downloading all the needed packages and executing the code in the browser. It's not running on any server. So this means that you can build any of your panel app and put it up on your own web page or GitHub pages. So it's super easy for you to share your dashboard with the world. And then you can see you can change different things and make your dashboard interactive. Yeah, so that's that. The final thing I want to share with you is the awesomepanel.org, where we can see some examples of the panel dashboard. So if you don't want to use panel convert and do the Jupyter, do the GitHub pages, you can use awesomepanel.org, where you write your own app and it will convert to a web page for you. You can log in with your GitHub page and you can host your app on this website. It's built by a community member of HoloViz. It's quite nice. And if you go to the gallery, you can see I have uploaded some demo here, and you can do a lot of powerful things with panel and with PyData and PyScript. For example, Here's an example where you can use your video stream to detect your face and do some facial detections. So here you can do different things and you can do facial detection. Yeah, and this also works on GitHub pages. So yeah, if you want to learn more about HoloViz, make sure to check out holoviz.org, which will include a more lengthy tutorial for you to go through, or check out the official documentations, panel.holoviz.org and hbplot.holoviz. And if you have any questions, go to discourse.holoviz.org. The core developers will be there to help you. Thank you. Any questions? Yes.
So I've spent many hours trying to program like the custom JavaScript in Bokeh. So if you wanted to customize your interactions, is that happening in JavaScript or is it part of this package?
Yeah, both. If you want to have your customized JavaScript embedded in panel, you can do that.
Okay.
Yeah. Yeah, if you search panel JavaScript, there should be a page of examples for you. Yes.
So how does, I've broadly looked at some of the alternatives. How does, say, panel versus, say, Matplotlib dash? What are the expenses? Are there both of them?
Yeah, that's a great question. Let me direct you to my blog post. I wrote a blog post about that. Let me see. Yeah. So this blog post is based on the one of the panel talks given by all the core developers from different packages. You can see here is a table of all the comparisons for 4 of the libraries for dashboarding. We have the Dash, Panel, Voila, and Streamlit. So the main difference are, yeah, does your tool support your favorite plotting library? Streamlit and Panel supports many. And if you use Jupyter Notebooks, Panel and Voila supports Jupyter Notebooks. If you need to build complex apps and use big data, Panel and Dash do that. If you need a lot of simultaneous users, Dash scales the best. And if you want to share your app with the public, Streamlit provides easy deployment. But now I think almost every app allows you to deploy to the browser now, so it's all pretty easy deployment.
I think I'm going to follow you on Medium today.
Thank you. Any other questions? Yes.
Do you love cats?
Yes. Is it obvious?
My sister does too.
Yeah. I'm quite proud of the cat picture selections I have here. Yeah. Yeah, I mean, I think this one's cool. Yes.
So you can do face detection. Can you do like any custom computer vision model?
That's a great question. The bottleneck is PyTorch doesn't run on PyData yet.
Okay.
So you need to have PyScript running on PyData first in order to have things running smoothly. I mean, PyTorch is on PyData, but PyTorch depends on so many other libraries, so it won't run. So hopefully it will come soon. Oh, now it works. Yeah, I don't know why it did not work before. Yeah, now it doesn't have any error message. Okay. It's a working demo now. Sorry about that. Thank you. Bye.